composition word is? Like a word that is a composition?
Yeah.
What does that
Composition
mean?
word, but
It's like made up of two things.
It's made up of two things, right? It's a word that's made up of two words. A composition of transformation is
Made up of two transformations.
beautiful. Okay, good. Way to connect the dots there. Okay, so we are, stop putting your hands in front of
Sorry, I just demonstrated how to put hand sanitizer on.
Okay,
Formative
so
use.
we are going to have some theorems, and a theorem is what again?
Sorry,
I'm done.
What is a theorem again? Focus, we don't have much time.
It's like a theory someone has.
Like
Oh,
something you have to
yeah.
follow.
We have theorems and postulates, right? What's the difference
Is it,
between the
okay,
two?
so a theorem,
Okay, and we'll make, what's a postulate?
well, postulate's a rule, a statement that is accepted to be true without proof.
Okay, without proof. What's a theorem then?
Is a theorem like?
It has proof.
Is it how
Is
you
that a
prove a
theorem that has
postulate?
proof, a postulate that has?
I just said that. It's how you prove a postulate. It's what you prove a postulate.
No, that's not right though.
It's a
It's not right.
statement that's true because it has proof.
What is it, Miss?
Can you just tell us? Not accepted as
I've
true?
already told you in the first lesson.
What? Yes, it's what you use to prove postulates.
Did I tell you postulates and theorems?
I do not have
No,
theorem
you
written
don't.
down.
Whole postulate. And I wrote down everything.
What's the
Well, we'll
definition
see.
for
Let's see
theorem?
if we can figure out as we do this.
Is this 1.7?
Okay, so two reflections and an intersecting lines, theorem 1. So that means there's gonna be more than one of these. Two reflections and intersecting lines, theorem 1, okay? Two reflections across a pair of intersecting lines is a rotation, with the intersections of the two lines as a center of rotation. So if I have this right here, this segment HG, and I reflect it over line B, okay? But line B and line A intersect, and I reflect it again over A, I now have a rotation. So two reflections make a rotation when it is reflected over two separate lines that intersect. Meaning, if I have this, let's say you have an X and Y axes. What happens if I reflect a point over the X axis right here? That's reflection, yes? If I reflect it again over here, I've now created a rotation.
See, wait, I'm confused.
Two reflections make a rotation.
Oh, I get it now.
Really?
Yes, I do.
Okay, so that's theorem 1. Two reflections and intersecting lines, theorem 2. The rotation is twice the measure of the angle between the intersecting lines with the intersection of the two lines as the center of rotation, meaning this. These two lines right here create an angle, yes, that intersect?
Not yet.
Okay, if that angle is 40 degrees, then the rotation is 80 degrees.
Yes.
It's double what the angle of intersection is. Okay, right here, this is 90 degrees, correct?
Yeah.
Yes, and I reflect and I reflect. What's that rotation then?
200.
No.
180.
Oh, no.
Because it went 90, 90, it's 180. Okay, 90, 90, 90.
Oh, I see.
So whatever that intersecting angle is here, see this, how this intersects right here where it was first crossed over? That was 90 degrees, yes? So this reflected once at 90 degrees and it reflected again at 90 degrees, making this angle of rotation 180 degrees. So the angle of rotation is double the intersecting lines angle. The intersecting lines angle is half of the angle of rotation. So you can work problems back and forth,
I found my protractor.
okay? What, Abby?
So when it says the center of rotation is the intersection, on like a normal graph, would it be like 0?
Yes, on a normal graph it would be 0, 0. Correct.
What would be 0, 0?
This is the point of, the origin is the rotation on this graph. So it's wherever the lines intersect.
Okay.
Okay. Oh yes, isometric transformations theorem,
Ew. I don't like that one bit.
okay?
Thank you, next.
Translations, rotations, and reflections are isometric. Do you know what isometric means?
Yeah.
ISO. Shut up, Alex.
Thank you for yelling ISO, Alex, but
You're welcome.
what does isometric mean?
Alone?
What does isometric mean?
Alone metric.
Why are you copying?
All he did was yell ISO, but what does ISO mean
No,
to
he
you?
said alone.
It means isolation.
Go random.
Leave me alone.
ISO means
ISO?
isolated.
Thank you, good.
I said
Oh my gosh, it's
I need you to start using English vocabulary to piece this together. So,
Mrs. McKinney.
isometric transformation theorem means that a translation, a rotation, and a reflection are all isometric, meaning they can all work alone, okay? They just word things funny. FYI, a theorem is a mathematical statement established by means by a proof. Meaning, a theorem has to be proved to be true. Does that make sense? Whereas a postulate we accept as true.
That's what I said.
I know.
Oh my goodness.
You're on it today.
This never
I'm
happens.
for everything.
I know. Yeah, I'm with you,
Caleb.
Okay, so let's say I have this point. Let's say I give you the point -4, 2. -4, 2, and I want you to rotate the point -4, 2 180 degrees.
Okay.
Okay?
Good.
Tell me what that new point is.
4 2.
Grab it.
4 negative 2.
Okay, 4 -2. Now, I want you to translate it to -1. What is that?
It'll be 6.
6.
-3.
6 -3. Okay, good. So what did I do there right now? What did you do to get that 6 -3?
You rotate it and then translate it.
You rotate it and then translate it. You did 2 types of transformations, yes? 2 types of transformations is a translation, a composition of transformations, okay? So you can apply it to 2 things.
I'm kind of
Where do you get the 6
confused
from?
on the true reflection image.
You added.
You add 2 to 4 and you add -1 to -2.
I'm still kind of confused with theorem 2. What does it mean, like? The rotation is twice the measure of the angle. I get that. 90 is 180.
If the angle where these 2 lines intersect is 60, then the angle of rotation is 120. It's always double whatever that angle is.
Okay, and then what's the intersection of the 2 lines is the center of rotation.
Yes, meaning like when they intersect right here, okay?
Yeah.
This point, that's this line segment that's out here is rotating, like it would be like it's attached to a string here.
Oh, I
And it
get it.
rotates here and then rotates there from this point.
Oh, okay.
Does that make sense?
Yes.
What, other questions? Okay, so let me talk you through some other terminology. There is something called a glide reflection, a glide reflection. What do you think a glide reflection is?
A
Where
reflection,
you
slide
slide
it
slide
and then
over.
reflect it.
When you slide to the left.
And then you do a reflection.
Slide to the
Yes, so a glide reflection
Is that a
is,
theorem?
it's not a theorem, most of this lesson is just vocabulary. A glide reflection, okay, consists of a translation and then is followed by a reflection. So it's a translation, then a reflection, which you guys just told me.
What's it called? Glide reflection?
Which would be considered what? If 2 things are happening, what does a glide reflection fall under? What category?
Translation.
Oh, composition.
A composition,
Oh, I totally messed with that.
okay?
I like messed
Composition.
So mean.
Composition of.
Composition means it's 2 things in one.
So a glide reflection is just a translation, then a reflection.
Yes, a glide reflection is a translation, then a reflection, okay? Listen, there aren't even like examples for this section because it's literally just these theorems and postulates and knowing what means what. So you need to study terms. Do you understand what I'm saying? Because this whole, well, maybe I don't have a second slide. Go.
Can you go down? I have your copy of the last one.
Can I what? The last one's not really anything fun.
Thank you.
Okay, turn to page 82 for me in your book. Actually, turn to page 81 for me in your book. 81.
I'm so happy.
So I want us to look at some pictures together. On page 81, you have another theorem, okay, a theorem. It says reflections in parallel lines theorem. Two reflections across a pair of parallel lines is a translation. So if I reflect and I reflect over parallel lines, I have a translation, okay? The translation is twice the distance between lines. You need to open your book for me.
I was still looking at the lines of mine walk.
Okay, so if I have parallel lines like this, okay, and I have this point, and I reflect point A over this parallel line, and then reflect it again. The lines have to be parallel, they have to be parallel, okay? And if I know that the distance between these two is 12, what's the distance from this point to this point?
14.
No.
I mean 24.
24.
Oh.
This distance is always double whatever these parallel lines are. Just like this distance is from when I'm doing a reflection and another reflection over coordinate planes, that this angle of rotation is always double the angle of where they intersect. It's the same concept, but with parallel lines. This whole length is double the length between these. So I can work problems backwards. Okay, meaning this.
How does that make sense?
How does what make sense?
Yeah.
Here's how this makes sense. This, if I reflected, that means, let's say this is, forget these numbers down here for right now. Let's say that this is 3 units, right? How far away does this point have to be from this line? If it was if it was reflected, 3, right? How far does it have to be away from this line?
3.
So how far does it have to be from there?
That makes sense.
So this would be 6 and this would be 12.
No, but you said that was 24.
I said forget those numbers, I was giving you new ones.
Oh.
Okay, does that make sense?
Yeah.
Okay, so it's like dividing it into 4 segments,
I get it now.
okay? The same with when I'm doing the angle, okay? If this angle is 45 degrees, okay? Then the part that I'm reflecting over, like if I reflect here to here to here, this part has to be double, okay? Because it's holding 2 of those 45-degree angles in there, okay?
Thank you.
Does that make sense?
Yeah.
Okay. So that is what on 81 they're showing us in that reflections and parallel lines theorem box, okay? That's what that means, okay? So then, if you look at the problem that's below there, number 81, okay, or on page 81, they have a line DC, and then they reflect DC, and then they reflect it again. Which one of those DCs is my original image?
The top one.
Okay, good. And then the second one has 1 set of dashes, and the third one has 2 sets of dashes, yes?
Yes.
Okay, so you can follow that. So when I reflect, it says, how far does DC translate if it reflects across A, then across B? Well, if it goes across A, and then across B, okay, I know that it has translated 6 units, right? Is that correct? Yeah, because it's 6 units from all of that. So the middle of the parallel lines is 6, the outers is 12, and so that's how you would do your math, okay? Flip the page, one more. I need you to look at these pictures with me, because it explains these same reflections that we talked about. What?
82 or
82? Flip your page one more. That's what I said.
Oh, sick.
Okay, on page 82, okay, look at these right here. See how these 2 things that we talked about say 2 reflections and intersecting lines, theorem 1 and 2?
Yeah.
Look at this page. It says 2 reflections across intersecting lines, theorems 1 and 2, but it shows you different pictures, yes? So it applies with line segments or it applies with shapes, okay? It's the same thing, okay? The whole shape just reflects. But the rules stay the same. If lines A and B intersect at point P, then a reflection in B followed by a reflection in A is the same as a rotation about that point P. If the amount of rotation, well, the amount of rotation is twice the measure of the angle between the lines, okay? So it's the same rules, same things. Yes, and then the composition theorem, any composition of isometric transformations, meaning a translation, a reflection, or a rotation, is isometric. Because the original things were isometric, then the composition is also isometric.
So isometric means it works by itself, and composition is if there's multiple things that works by itself?
Yes. Like if I have a composition, I'm doing two of the things, right? It doesn't matter if I do two translations or two rotations or a rotation and translation. But because each is isometric individually, together they're also isometric. Okay?
But they're also compositional.
But they're also still a composition, yes.
Okay.
Okay. That is what this lesson's about. See how I said there's not really examples to go through, we just have to talk through some things and get an understanding, okay? So here's the deal. On your homework, let's say that they tell you.
Homework?
Well, yeah,
No, we just study.
doesn't matter, you can still have homework. Let's say on your homework, they tell you that this is like, let me think here. What if they just give you variables like that's X and this whole thing is like, sure, 25. That's a rough number to work with, but okay. How would you figure out what X is?
You divide by 3, divided by 2.
You divide it by 2,
By 2.
because it's half,
One of the,
okay?
wait. I mean, excuse me.
But it's 3 parts.
Where's number 20?
Chloe,
The 3 parts aren't equal.
remember when we just talked about?
It's
the
actually
five-
4 parts, Chloe, 1, 2, 3, 4.
Oh, yes, I remember now.
So this is 2 of the 4,
Oh, okay.
so it's half.
Okay.
So when you have to like work this out, you divide by 2 and then that, one of them is the first, or the second one. And then you divide the other, so if you, if you had like, 20,
Mm-hmm.
and then you had 10, like 2 10s,
Yeah, so you have
So
10
one that's
here
10
and you
here.
have 20 here.
but then it's 5 on each side.
It would be 5, 5, 5, 5.
Okay.
Shane.
Okay.
That's what I did.
So yeah, so that's what you're gonna work on tonight.